Okay, so today we are learning about inverse functions. What's an inverse? English. Geometry, yes. Opposite. I like it. That's exactly right. The inverse is a function, or functions that undo each other. They're found by switching the x and the y. So they're opposites. So why do we need to know this? Why is this something that's important? How many of you are in science class right now? In science, what system do they use usually to measure things?
A metric system.
A metric system. What's temperature in a metric system?
Kelvin.
Kelvin or
Celsius.
Celsius. What's temperature in our customary unit in the United States?
Fahrenheit.
Fahrenheit. So how do you switch from Fahrenheit to Celsius? It's like
Divide.
9/5 times x minus 32 or something like that, right? You also have an equation that switches from Celsius to Fahrenheit. Or did I say that? I don't know. Whichever one I didn't say, it does that. So you have an equation that goes from Fahrenheit to Celsius. You have an equation that goes from Celsius to Fahrenheit. Those are inverse functions. If you start with the temperature in Celsius, 40 degrees Celsius, which is pretty high, and then you switch it to Fahrenheit, and then you get some number, right? That number that you get, you plug it back into that other, you plug it through that other function, get back, you should get back 40 degrees Celsius exactly, right? Those are inverse functions. How many of you want to travel outside of the United States or have?
I've been stand up for 10 minutes.
If you go to a different country, do they use US dollars or do they use a different kind of currency?
Pesos.
Pesos. Some use pesos here. They use different kind of currency. Absolutely. So, how many of you know Jan? Foreign exchange. He's from Switzerland. So in Switzerland, they use Swiss francs. So there's a conversion from US dollars to Swiss francs and back. If you give them $500 US, you want to get back $500, right? You don't want to get shortchanged. That's why inverse functions are important. Okay, so I want you guys to plot the given points. And then connect. I'll plot the inverse points. Raise your hand if you know what we're doing right now. Look back up to the top of your note sheet. What do we write down?
Switching the X and the Y.
Switching the x and the y. Great answer. So what do you think you do to find the inverse points?
Switch them around.
Switch them around. Something that looks like that. Okay? So what do you guys notice? Yes?
No, one of them is this one.
So one of them is x squared, right? The parabola. What's this one? What parent function?
Square root.
Square root. How do you undo a square? If you have 36, how do you get 6? Square root it. If you have 6, how do you get 36?
Square.
Square it. So those would be inverse functions. What else do you guys notice?
Did I say x squared US? Or is that a b?
Yeah, the handwriting. VS.
Ah.
Like versus. Just making it way worse. Looks like it tells you to. Okay, anyway. What else do you guys notice about that? You already noticed you switch the x and the y, right? How about, are there any, look at the graphs. Are there any reflections there? How do you get from this to this? Yeah?
Reflection.
Over.
Just in the x-axis.
Okay. So if you reflect over the x-axis, you have something that's going like this, right? I want to go like that. What if you reflect over the y? It'll be that, right? So it's not reflecting over the x and the y, but it is a reflection. What's it reflecting on?
It's still
Nothing. It is a reflection though, so it has to reflect over something.
itself.
Itself. I don't know about that one.
Points in between.
The points in between. Yes. What line are the points in between them?
0, 0, and 1, 1.
0, 0, 1, 1, 2, 2, 3, 3, 4, 4. What equation is that? The linear equation, exactly. What's our equation for that? Yep. Y equals x, right? So inverses are a reflection over the line. Y equals x. So if you ever need to check your answer, if you ever like, I don't know if these are inverses or not, if you come and plot them, it should be completely symmetrical. So you see how this is 2, 4. What's this one? 4, 1, 2, 4, 2. They're equidistant. Okay. Now most of the time we won't do points and graph, and we don't do it on grade. So what you do? Okay. So you're finding the inverse of f of x equals 3x minus 1. First step is you replace this f. Actually, yes, you replace the f of x with y. So you guys probably learned functions in 8th grade, right? 7th, 8th grade. So when you learned functions before that, you always had y equals 3x minus 1, right? And then someone was like, hey, you know, you can just take y out and put f of x in. That's how you do function number 8. Does that ring a bell to everybody? No? Okay. So f of x is just a way of writing y so that we don't have to say like, solve for x equals blah. We can just put f of 6 and solve for 6. So this notation, when you're finding the inverse, this is what you do. You take out f of x, put it in y, and then you switch, top switch, x and y. And then you solve for y. So we have to add 1. X plus 1 equals 3y. Divide by 3. Get y equals x plus 1 over 3. Now that looks kind of funky, right? So what is this 3 doing? Dividing x plus 1. So it's dividing x and it's dividing 1. So this can be written as y equals x over 3 plus 1 over 3. What's another way you can write that? What's a way you can graph it? Slope, right? How do you get the slope?
Multiply by 3.
Multiply by 3? No? What is this? That's right. You have x over 3. What is x over 3?
Up 1 over 3.
Up 1 over... Exactly. How do you show that? Y equals mx plus b equals 4. What's your n?
Huh?
What's your n? 1/3, right? 1 over 3.
What?
Okay, so the slope is 1 over 3, right?
Yeah. Up 1 over 3.
X
Plus 1.
plus
1
1.
over 3, yeah.
So x divided by 3, x over 3 is like saying x times 1/3. That's what fractions are.
Are we okay with that? Well, x over 3 is the same thing as 1/3 x.
Yeah.
We've seen it before, I just want to cover that again.
Yeah.
Why did you switch the x and the y?
Why did you switch the x and the y? For inverses, we switch the x and the y. That's how we find them. And then the process is you switch the x and the y, and then you solve for y. That way, you get a new equation that is exactly the opposite of the old one.
So we started with f of x equals 3x minus 1. That's our function. And now the inverse, which we have just solved for, is y equals 1/3 x plus 1/3. You want to square that, Mr. Warren? You want to square that? And not square as in mathematically square, but circle
Oh,
our
yeah.
inverse. That is what we got as now our inverse. Were there questions about how we went from a function, switch the x and y, solve for y, and now have our inverse function? Are there any questions there?
So how can we check this to make sure that we got the right inverse? Graph it. Exactly. So we have 3x minus 1. Your y-intercept is -1. Okay. Slope of 3 of 1, 2, 3 over 1. 1, 2, 3 over 1. 2, 3. 1, 2, 3. Our inverse. We have a y-intercept of about 1/3. There, right? Go up 1. 1, 2, 3 over.
Start at -1.
Up 1, 1, 2, 3 over. Like that line. first line, okay? So, I know. Okay, here we go.
Oh.
So yours can,
Is that just supposed to be up 3 over 1?
yes. So you
Oh,
just
first
graph
dot's
the
off.
original.
The first dot's off.
The first dot's off. Where?
Yeah. Over 1. Oh,
Up 1, 2, 3 over 1.
Our y-intercepts are J.
Yeah,
That comes 0, 0.
because our y-intercept is negative
Oh.
1 here, right?
oh.
So the line that is steeper, guys, the steepest line is our original function. Right there. The one that's not so steep, as a slope of 1/3, is our inverse function. What do we notice about those two functions?
What do we notice?
Oh, what?
What do you notice about those two graphs?
They're the opposite. So they are inverses, and what are they a reflection over? Yep. Anybody have any questions for me? Yeah.
What did you graph this like?
So your y-intercept is 1/3. So I just went a little above that, the x-axis, for a third, and then went up 1 over 3, up 1 over 3. So I want you guys to change this x squared to x squared minus 3, since we already did x squared. What's my first step? Easton. That's my first step. Just read that on the last one. I have to get rid of that first, right? Yeah. So y equals x squared minus 3. Switch them. X equals y squared minus 3. And then Easton's absolutely right. Add 3.
Bless you.
Equals y squared. Now what do we do?
Yeah.
Yeah.
We just like graph the first one first.
You could do that. Absolutely. You can do it either way, whatever you like. Now, you're going to get into harder functions and stuff, and that might be easier to do algebraically. But for some of these, it might be easier to graph, which is your own taste, yeah?
Why did you write? What was the first step? How did you get from the function to the y squared?
So f of x and y are interchangeable in algebra. We use like y equals something x, right, to solve equations. Well, we can also use f of x equals something x. So I can just change those out because they're the same thing.
What does the last thing say?
X plus 3 equals y. So how do I get rid of the square root of y? Because I need y by itself for solving for y. Square.
Take the square root.
Square root. So I get y equals square root x plus 3. Okay? So that's your inverse function. Now, so if we can graph it, so you have x squared minus 3. Where does that be? Alyssa, where's my y-intercept? 3? Yeah. -3. x squared graph. Something like that, right? Yeah.
Negative.
I'm just stretching.
Is this the first function
What?
or the second one?
We are graphing the original function right now. First. Now we're graphing the inverse. So the square root graph, what does that look like? Same thing.
There's a plus.
Opposite.
Opposite.
Well,
Thrown
it's
out answers.
Banana. No?
What?
Okay.
isn't it a different line?
What?
Isn't it a different line?
It is.
It's a square.
What's the parent function for square root? If you have to look in your notes from the other day. Yeah, like this, right? This one?
Yeah.
Goes like that. That plus 3, is that our h or our k value?
That is R. Well,
That is h. You're right. So what's important about it's a liar. So instead of going 3 right, go 3 left.
Ooh, good.
Go like that.
what is that?
Y equals x.
Nice. That makes sense.
Did you hand if you have questions? Why is it linear?
Why is it linear?
Why is it linear?
Like,
Anybody know why we always get it reflects over y equals x?
repeat that?
Why do we always get this to reflect over y equals x?
It's inverse.
Because it's inverse. You're right. Do you know why?
Because the sheet says.
Because the sheet says so. Like the answer. Okay. Basically, you always get y equals x because it's 2 reasons. The main thing, though, is, as we'll see in a little bit, when you compose the functions, so when you do f of, that means f inverse of x, you get x, right? When you plug in 40 degrees Celsius, switch it to Fahrenheit, you should get 40 degrees Celsius when you do the inverse. Okay? So that's why you get x, because you're plugging in x. Now you also get x because it has to equal the same thing. The only way it's going to equal the same thing is if it equals x. Yes.
All of the equations gonna be linear.
No. This one was linear.
Well, I mean, like, are they all gonna reflect over the linear?
Yeah, absolutely. Because you're always going to get that they equal x when you compose them together. Let's look at that real quick. Okay, so when a function and its inverse are composed together, you'll get f of x equals x. So we have f of g of x. What am I plugging into f of x? What's my inside function? G of x, which is
X plus 1 over 3.
x plus 1 over 3. That equals 3. We're plugging in this for x plus 1 over 3 minus 1. 3 times something divided by 3. What does that give us? Someone said it. 1, exactly. Those cancel out, right? So then you're left with x plus 1 minus 1. What's 1 minus 1? 0. So this equals x. Now do the other.
F. So it's F and then x plus 1 over 3 is what the answer is for x.
Yeah, well, So when you find f of g of x is x plus 1 over 3. So then f of x plus 1 over 3 is equal to x. Okay. Now let's do g of f of x. G of 3x minus 1 equals 3x minus 1 plus 1 over 3. That's what we plugged in for the x of g. Okay. Now, what's negative 1 plus 1? 0. 3 divided by 3? 1. So we're just left with x. So g of 3x minus 1 is x. That can also be written as g of f of x equals x. Yes?
So the 3's cancel and the 1's cancel out each other.
Can you repeat that? I'm sorry.
The 3's and the 1's cancel out each other.
Yeah. So look at here. You have negative 1 plus 1. That's just 0, right? When you add 0, it's nothing. 3x divided by 3. Just go like that. We're just left with x. Yeah.
So, what do you just leave the function that was in the first one by g? Do you just leave that alone? That doesn't cancel?
Not sure what you're saying.
Like, that first function, the second function cancels out. The second function cancel out with the first one too.
No, it did too. See how, okay, so the 3's canceled, and then once the 3's canceled, we could subtract this 1.
A second example,
Okay?
that first function after the g, and this is 3x minus 1 equals 3x minus 1 plus 1.
Yep.
The second function canceled out into the first one.
The second function canceled out.
Like the left side of the equal sign.
This is just notation. This is not,
You don't do anything with that?
nope, that's just notation. Yep.
Phil, I'm gonna help to answer your question. If we had f of x equals x minus 3, and I want to find what f of 5 was, what do I do? I don't know multiply, but I'm going to plug 5. This isn't multiplication. This means, hey, I'm going to replace x with 5. So I put 5 in there. 5 minus 3. What's 5 minus 3? Is what? 2. So that's 2. Basically, again, like Mr. Wentz said, this is just notation. This just represents, hey, this function that we're calling f of x, that's f of 5. Okay? Set right here. It's like, hey, this, we're going to compose them. This g function, but g of that is x. Does that make sense? If it's in the parentheses, if it's g of something, f of something, h of something, m of something, it just means, hey, that's what we're plugging in for x. Does that help?
Do we have any other questions? Okay. So we have f of g of x. Someone give me what g of x is.
Square root of x plus 1 over 2.
Over 2. Exactly. So that equals f, we've got 2, x, which is square root of x, plus 1 over 2, squared, minus 1. So what goes on with, I'm sorry, that was my bad. Okay. So how do you undo a square root? You remember what we talked about? Square. What are we doing here?
We stop here for a second.
Yep.
Guys, the big question is, what do you do first? I get this long, basically, expression, if you will, with just numbers. How do I know what to do first? Do I add 1 minus 1? Do I multiply by 2? What do I do first? What's in the parentheses? Is there anything to do inside the parentheses? No, there's not. Nothing to do. Then we go to what? Exponents. We're just doing PEMDAS, order of operations. Okay? Go.
So you do your exponent, that gets rid of the square root and the squares there. So you're left with 2 times x plus 1 over 2 minus 1. 2 times something divided by 2 cancels out. Get x plus 1 minus 1. Plus 1 minus 1 cancels out. You get x. So f g of x equals x.
Will it always come out to be just x?
If they are inverses equal. So if you get x plus 3 here, you know they're not inverses. Does that make sense?
Yeah.
Okay.
That's our goal, to verify, to show that these are inverses, we should get x. If we get anything else besides x, they are not inverses.
So we're halfway there. Because both of them have to equal x for them to be inverses. So we have g of x. G is our outside function, f of x is our inside. So we have square root g of x equals square root of x here, plug in f of x, 2x squared plus 1, no, sorry, minus 1. 2x squared minus 1 plus 1, and then that is all over 2. So, talk to your partner real quick. What do you think our first step is here? Partner is the person sitting next to you.
Figure space go out.
Hang out for here in a second.
What you guys call
Divide.
divide? Okay. I'd do something else first, but you're on the right track. Subtract. These will cancel out. -1 plus 1.
Mr. Wenk, we can just stop here. Order of operation, guys, this is something that we covered a long time ago. Order of operations, we do parentheses first, no parentheses. Well, we kind of act as the square root as our parentheses. We go inside that. Then from there, we do parentheses, we start all over. I do parentheses, exponent, there's nothing to do there. Then we do multiplication division. But the problem is, when we have a fraction, we want to do everything in the numerator first, and then everything in the denominator, and then divide. Does that make sense? So you're thinking divide because that comes first in order of operations, but if there's a fraction, we have to do everything in the numerator first. Does that make sense, Jaden? That's why we're adding in the ones together.
So you add the ones together, then you have 2x squared divided by 2. Those cancel out as well. So you're left with g of f of x is equal to the square root of x squared. What does that give us? F or x. Exactly. So are these inverses? Yes. Yeah. Okay. Anybody have any questions? Feel pretty good about this? Okay, well, our homework is (281), 13 through 20, 6,
Computers out. Computers out. Sign on the plan book. Okay, the book page that's scanned in on the plan book.
Do you have any questions, Mr. Cole? Be around.